Hey YouTubers, welcome once again to LG Edit Triple E tutorials. In today's edition, we are going to be looking at question 4 of Field Theory 2 Electrical Electronics, Rivers State University past question. We'll be looking at question 4b. Question 4b says a plane traveling wave has a peak electric field E naught equal to 8 volts per meter if the medium is lossless with the relative permeability to be equal to 1 and the relative permittivity to be equal to 3. Determine 1. The phase velocity of the wave, 2. The peak pointing vector, 3. The average pointing vector, and 4. The impedance of the medium. So before we go into solving this question, don't forget to like, subscribe, and also hit the notification bell. Thank you. Okay guys, now if you look at the question 4b, here are the given parameters. We have your peak electric field to be 8 volts per meter. Then your permittivity. Okay, permeability is 1 and the electric permittivity is 3. So what we're looking for is the peak pointing vector. We're also looking for the phase velocity. We're looking for the average pointing vector, and we're looking for the impedance of the medium. Is supposed to be your phase velocity here. This is phase velocity. I used P. Now the formulas to use is the peak pointing vector is equal to the square root of electric permittivity divided by the magnetic permeability times the square of the electric field. Then it's the same thing as if you're having a magnetic field. What you see is that the magnetic permeability came up in the square root all over the electric permittivity. So it is the reverse, then times the square of the magnetic field, or the peak magnetic field. Here is the peak electric field, whereas the average is just 1 over 2 of the same formula. 1 over 2 of the same formula. That's simple. Then your impedance is always equal to the square root of the magnetic field, the magnetic permeability divided by electric permittivity. Then the electric permittivity is the same thing as electric permittivity of free space times the electric permittivity of the medium. The same thing here, the magnetic permeability is the same thing as the permeability of the medium and the permeability of free space. Then your phase velocity is the same thing as 1 over the square root of the permeability of magnetism times permittivity, or it is the reduction in the speed of light, because speed of light here, c, is the same thing as 1 over the square root of mu naught, that is the permeability of free space, and epsilon naught, permittivity of free space. That's what you do to get 3 times 10 to the power of 8 approximately. That's the speed of light. So it is the speed of light divided by the permittivity of each media. So the speed of light is reduced by the permittivity of each media. That will give you your phase velocity, or simply just use this formula. Now with that, we can solve for what we want. The first one was to find the phase velocity. Now the phase velocity is 1 over what? Square root of the permittivity. Remember we said permittivity is permittivity of the media times the permittivity of the permeability of the media times the permeability of free space. Same thing goes to permittivity of free space and the permittivity of the media. So if you do that here, the permeability of free space is equal to 4 pi times 10 to the power of minus 7, whereas for the media it was given in the equation to be 1. Same thing, the permittivity of the media is 3, and the permittivity of free space is 8.85 times 10 to the power of 12. So you put that in, punch this in your calculator, you're going to get 1.73 times 10 to the power of times 10 to the power of 8 meter per second. Same thing goes to the peak pointing vector. Now for us to get the peak pointing vector, like the formula was given here, just to put the permittivity of free space times the permittivity of the media all over permeability times this, then you punch in your calculator. After everything, you're supposed to get 0.29 watts per meter square. This is your easy unit, SI unit, for permittivity of the peak pointing vector. Same thing goes to the average, 1 over 2 of the 1 over 2 of the peak pointing vector. So 1 over 2 of this will give you this. Then your Z is square root of the permeability divided by permittivity. Now the permeability is 1 times 4 pi s. We all know that. I've explained that before. So after everything, you get Z to be equals to 217.56. So with this, you're able to solve this particular question. If you have any question, you can ask me on the Q&A section. If you have any comment, you can also make there. Don't forget to like and subscribe to my channel.